Welcome to Lesson 9-4 of Unit 6A. In this, we're going to see some patterns happening as we're multiplying binomials. These are called special cases. We're squaring a binomial, and then we're also looking at the difference of two squares, or the difference of squares in this. And again, all of these can be done with the FOIL method. However, I want you to start to see the patterns and pick up on some things as they're happening. So here, when we're squaring a binomial, if we have a plus b and the quantity is squared, the result's going to be a squared plus 2ab plus b squared. If we are squaring a binomial that's subtraction, like a minus b, the result is still a squared. However, now we have the minus 2ab and then plus b squared. Okay, and then we've got the difference of squares. So that occurs when we have a plus b times a minus b. And again, hopefully you'll start to see how our outers and inners kind of cancel each other out, and we're just left with this a squared minus b squared. So in our first example, we've got y plus 11 quantity squared. And again, remember, that just means y plus 11 times y plus 11. Okay, and so our first term is going to give us y squared. And then our outers is going to give us 11y, and our inners is going to give us 11y. See how that happens there? So 11y plus 11y gives us 22y. And then our last term of the trinomial here is 11 times 11, which is 121. See how we did that? So in our next example, we've got a subtraction. We're squaring a subtracted binomial. So we've got 3w minus 6. So hopefully you're starting to pick up on the pattern. If you're not, try it out. Again, practice makes perfect. And so we've got 3w minus 6 times 3w minus 6, okay? And so 3w times 3w gives you 9w squared. Minus 6 times 3w gives you minus 18w, and then our outers and inners make the same number, so that totals up to minus 36w, minus 18w, and then negative 6 times negative 6 gives us that positive 36. In our next example, we are looking at a real-world application of why we would square binomials. In this case, we're looking at Punnett squares. If you think back to some genetics you might have done in 7th grade, when we're looking at guinea pigs here, and they have black fur, which is dominant, and then white fur, which is recessive, okay? So when you've got a guinea pig that is presenting dominant with black fur, it's either going to be BB, which is dominant, and then or it could be dominant and then carry that recessive gene, okay? And so that Punnett square model, we can see here how we're actually multiplying the genes and what the result's going to be. Notice how we get one square that's going to have that dominant, and then one square is going to be recessive. That's where that 25% recessive comes in. And then you also have a combination in which you're going to get a dominant and a recessive gene there. Okay, so we look at that and we start to think about what's happening when we can multiply that 1/2 B plus 1/2 W. That's what a black fur dominant exhibiting guinea pig with a recessive gene that's kind of hiding behind that dominant gene, okay? So one gene is dominant, one gene is recessive, even though they present to be dominant, right? And so when we're multiplying, let's say we have two parents that are both dominant with a recessive gene, the result's going to be this binomial squared, okay? And it follows the same pattern that we've been seeing here, Okay, so just kind of imagine what's happening there. Some of those fractions, again, multiplying fractions, I know a lot of you don't like to do that, but it's that automatic of what's 1/2 times 1/2 and 1/2 times 1/2, and then we're doubling that. That's where we get the 2 from, or the 1/2, the black and the white genes, and then the 1/4 recessive. All right, let's see how we can use our binomial times a binomial to square some numbers mentally without grabbing that calculator, because I know you all want to do that right now. So 81 is the same as 80 plus 1, correct? 80 plus 1 quantity squared, right? So if we start to follow our same pattern, and we notice that we can take our first term and square it, and we get 6400, right? And then our outers make 80, and our inners make 80, so that gives me 160, and then our last term squared is 1. See how I did that? So now if I just add those up, 6,400 plus 160 plus 1 gives me 6561. See how I did that? And again, let's try that again with 59. Now, 59 is the difference of 60 and 1, right? So again, if we follow that pattern, 60 squared is 360. Our outers and our inners make 120. And then our last term is plus 1. Oop, forgot the 0 there. So now if we combine all of our values up, we end up getting 3481. So here we have the difference of squares. And so watch what happens when we FOIL. P to the 4th times P to the 4th gives us P to the 8th. Okay, and then our outers make P to the 4th times 8 gives me plus 8 P to the 4th. Our inners make minus 8 P to the 4th, and then our last terms make minus 64. So we can see here how our outers and inners cancel each other out, and we're just left with P to the 8th minus 64, which is the difference of two squares. In our final example, we're going to use that difference of two squares again to see if we can multiply this quickly. So 43 is 40 plus 3, and 37 is 40 minus 3. See what I did there? So now using that quick math, I know that my outers and inners are going to cancel out. So if I square my first term, I get 1600, and then I square my last term, I get minus 9, for a grand total of 1591. See, I didn't need to grab a calculator for that. If you don't believe me, go ahead and check it on yours. Don't forget, as always, complete your post-video check and ask questions if you have any.